my end also. Okay. So today I'm going to start a very important topic, IP subnetting. And before I just start today's session, let me quickly like review yesterday topic. So yesterday, like where is this pen? Just give me a minute. There seem to be some issue. Okay. So this time. So, something wrong with the digital pad, no problem. So I will fix it later on. So there seem to be some issue with my digital pad. It's not working, but no worries. Let me open this. Okay. So yesterday, we talked about subnet mask and default subnet mask class A like 255.0.0.0. If I convert decimal value in binary, so 255 equals to like 8 ones and then 3, 4, 5, 6, 7, 8 zeros, and then again 1, 2, 3, 4, 5, 6, 7, 8, and then 8 zeros again, 4, 5, 6, 7, 8. So basically 255 equals to 8 ones in binary. Zero means like all zeros, total 8 bits, again here 8 bits, and here 8 bits. And in this class A, network bits is equal to 8 because total there are 8 ones. That's why. And host bits, host bits is equal to 24 because there are 24 zeros. That is why. So 8 ones and 24 zeros. 24 zeros. Okay. So as per default subnet mask. So if I write down class B in the same way, here, and also class C. So in class B, 255 is the default mask, and here all ones 1, 2, 3, 4, 5, 6, 7, 8. So 16-bit network, because 16 ones, 16 zeros means 16 host bits. And in class C, 255.255.0. So here again 255. Okay, so 3 octets with all ones here again, and 24 ones and 8 zeros. Here it is, 8 zeros and 16. Okay, so and this is a default subnet mask without any manipulation. So as per the class rule, class A means like first octet represents network portion, network bits, and 24 host, total 32 bits, 8 plus 24. Class B, 16 bits network and 16 bits host, total 32 bits. In class C, initial 3 octets means 24 bits in binary represent network portion, and last 8 bits host portion, 8 zeros here. This is the default mask. And class C, if you remember, so yesterday we discussed this point that class C network is the smallest one, smallest network, class C. So class C is the smallest network. In fact, total in class C, if we have to calculate maximum number of IPs are hosts, one and the same thing, then this would be equal to maximum number of IPs equal to 254. And why 254? Because total there are 8 bits in binary to represent host portion, and it's all in binary. So binary means like the total number should be here 2 raised to the power 8, and 2 raised to the power 8 means 256. But out of 256, 2 IPs are reserved, and that is why we are going to subtract -2. And why 2 IPs cannot be used in any specific class, because the first address and the last address, so valid address is 254 because first address is reserved. Let me write down here. First address reserved as network address. So I'll be using this network address in routing, but we cannot assign like first address to any end device, in fact. And last address, the very last address, reserved and used internally by computers, devices for broadcast purpose. So known as broadcast address. So first address and last address, these two addresses of any class network, both are reserved. First address, network address. We cannot assign network address to any host device. And even the last address, again, cannot be assigned to any device, in fact, because last address is broadcast address of that specific network class. So that is why we subtracted 2 IPs. So maximum number of valid IPs, valid, valid IPs means that IPs that can be assigned to end host devices. So valid IPs is equal to 256 minus 2 equals 254. So total 254 IPs are available in Class C network, and Class C is the smallest network. The smallest network. Class A is very big, and Class B is in between A and C. And how do we calculate number of IPs in any specific network? So we take number of zeros, because number of zeros represent host portion, and 2 raised to the power number of host bits and then minus 2. So that's the way how computation is done. So similarly, if let's say if I have to compute or find out maximum number of valid IPs or hosts in class B network, then this would be equal to 2 raised to the power and then number of zeros. So count number of zeros, 8 here and 8 here, 16. So 2 raised to the power 16 and then minus 2, again minus 2, because 2 IPs reserved. So here in this class B network, 2 raised to the power 16 equals to 65,536. You can use calculator for computation purpose, right? 65,536 and then minus 2. So valid IPs in class B network is equal to 65,534. So even by using same formula, same method, we can easily compute maximum number of IPs in class A network also. In class A network, total there are 24 zeros, 24 host bits. So 2 raised to the power 24 minus 2. And minus 2 because first and last address both are reserved in any specific network class. So we have to keep this in mind, like first and the last address in any network class is reserved. So we cannot use first and the last address in any network class. Now, if we take example of public IPs, so since public IPs are limited, like already we are running out of public IPs, right? So we cannot afford to waste public IPs, in fact, because they are not free. They need to be globally unique. Private IPs, yes, we can afford to waste IPs, no problem. So in let's say I have a home network and I have total 10 end host devices, 10 computers. So yes, even I can go with class B or class C address, no problem whatsoever, because IPs are private. We are not going to pay for those IPs, and private IPs need to be locally unique only. So really, we don't care about like wastage and other stuff. But over the internet, yes, it's very important. Even Class C network is big network, in fact, because there are 254 IPs. So the solution here, like in case if let's say 254 IPs not required, like we need maybe one or maybe two, 10, 20, 30, 40 IPs, right? So we don't have any class for that because there are only three classes. We don't have like 500 or 1,000 different classes, right? So only three major networks, three major classes: class A, class B, and class C. And that's where this new topic, subnetting, comes into picture. Subnetting is used to address this problem. Subnetting is used to minimize wastage of IPs, or in other words, subnetting is a technique, a mathematical computation used to logically divide a large network, a big network, into multiple small networks, right? So for example, in this class C, even my keypad is not running, but I can use with the mouse. So in this class C network, is class C network means like 254 IPs. This class C network can further be divided into maybe 4 subnets, means 4 small networks, right? And each network now can have 62 IPs, 62 IPs, 62 IPs, right? So this way, let's say an organization or company requirement is to have maybe 60 public IPs. And if service provider has already done this subnetting, right? A network is broken into four or maybe eight or 16 a small networks, subnet, right? So this entire subnet IP can be provided to a customer, right? So even like customer a client requirement is 60 IPs, and if service provider provide this entire subnet range, means like 62 IPs, still there is wastage, but hardly wastage of 2 IPs only, because customer requirement is approximately 60 and service provider has given 62 IPs, right? So wastage cannot or can never be zero, but at least we can minimize that. Let's say customer requirement is just to have maybe 20 or 25 IPs total. So what service provider can do? Service provider can divide this this class C network maybe into uh, 8 subnets. So a big network is further divided into 8 subnets. And now this each subnet can have now approximately 30 IPs, right? So we cannot do like subnetting or networking in such a way that only 20 IPs or 25 IPs in a network, right? We can reach to nearby, maybe like 30 IPs or 20 or 25 IPs. So still, if a pool of 30 IPs provided or assigned to one of the customer requirement is 20 IPs. So still, there will be wastage of 10 IPs, right? So yes, like wastage can never be zero. I mean, like because there are certain formula, there are certain rules. In fact, mathematical computation we do here. So it's not like we can like compute exact number of IPs. No, it's all in binary. So either like a small network can have maybe 62 IPs or maybe 30 IPs or further maybe 14 IPs or and you'll understand like why I'm writing all this. Maybe 6 IPs, maybe 2 IPs, maybe like 126 IPs. So network can be divided right further logical division, and now this each small network or subnet can have like 62, 30, 14, 6, 2, or 126 IPs. So at least in class C, even like is not looking very good option here, right? Uh, but think about class A or class B. If class A or class B network, even in class B, total like in single network, there can be maximum 65,534 IPs. And if we divide this network into small subnets, very small subnets, maybe a subnet with only maybe uh, something 130 or 126 IPs, only 126. Customer requirement is 100 IP. Still, there will be wastage of 26 IPs, but only 26, right? And without subnetting, you understand 65,534 IPs in the network. Customer requirement is 100 IPs. So what will be done with remaining IPs? I mean, like 65,434. They all will remain unused, unassigned, because two companies, organizations can never have IP address from the same IP network. They both need to have different networks. So that's where like this subnetting really plays very important role. And this is the main reason, because the first question that comes to our mind is like, why do we do subnetting? I mean, like if there is a network, so logically we are dividing this large network into multiple small networks, either keeping in mind the maximum number of IPs per small network, or maybe the number of subnets. This big network uh, has to be divided into 2 subnets, 4 subnets, 8 subnets, or 16 subnets. So either way, like either keeping in mind like this, or taking number of IPs into consideration, or maybe taking number of subnets into consideration. Whatever method we use, and that totally depends on the requirement, what requirement you have, right? And it's very common practice, and this subnetting is very common practice, and done by the service providers, internet service provider, because they deal in like public IPs, and public IPs we all know now that public IPs are not free to use, and very limited IPs we have, right? So yes, it's very common practice. So in order to do all this, I mean like subnetting and all that, like there's certain rule, and we will have to follow that rule. In fact, the method, in fact, will have to do some mathematical computation, binary to decimal computation, and once like everything is successfully done, then yes, like you'll find small networks, right? A big network logically divided into small networks, and how many IPs would be there in each small network, that depends like how we have done the subnetting, right? And and how we decide that, so totally based on requirement, what requirement you have, whether like you want to divide this network into just 2 small networks, 4 networks, 8 networks, 16 small networks, right? So based on that, we just perform mathematical computation. So, but that is subnetting. And so subnetting, what problem subnetting is going to solve? Subnetting is mainly solving like judicial use of IPs, right? So basically, it minimizes wastage of IPs, right? And of course, if we are using uh, small networks in even in private networks, so yes, like there will be like optimization optimization of optimization, because like it is used in network segmentation, and also like better management and administration. So because the first point like judicial use of IPs means like minimizes wastage of IPs, is more relevant in case of public IPs, right? So now, if your question is like, what if I have my private network? Private network means not internet. Is my network is private network, enterprise network, right? So do we need to do subnetting? Do we like use subnets in private network? Because in private networks, like we will be using private IPs. Private IPs are like free to use. We don't have to ask anyone. We don't have to obtain private IPs from internet authorities, right? And even they need to be locally unique only. Private IPs need to be unique in that organization only. So of course, like we don't care about like this wastage and all that. But there are some other points also, right? Let's say if you have total 500 computers, and if you plan to design a single network of 500 computers, right? You have like done physical connectivity first, because now you understand like networking means like first step is physical connectivity. Let's say you have finished like doing physical connectivity, like computers are connected, right, with the centralized devices, switches are also connected with each other, different floors, different buildings. So this way, all 500 computers are like connected with each other. All right. Now, the next part is IP addressing, right? Because TCP/IP protocol, you don't have to install. Already we have discussed this point. TCP/IP is what? Default protocol. Default protocol, right? So you don't have to install TCP/IP. on any computer. TCP/IP is the default protocol. So, but IP addressing, yes, we will have to assign IP address, right, to all computers. So let's say if we, of course, we cannot go with class C IP address because class C means like total 254. So we'll have to go with this class B network, class B, class B address, right? And total there are 500 computers. So 500 computers, single network, class B address. So as so there is no problem, but from optimization point of view, from segmentation point of view, it's not good design, in fact, because if total there are 500 computers in a single network, let us assume if one of the computer sends or generate broadcast message, broadcast packet, right? And a lot of broadcast packets are automatically generated in network. And I'll explain that once like we have finished TCP/IP. This is the last discussion of TCP/IP subnetting. Then I will just talk about this communication. I mean, like how computers communicate with each other by using IP address and hardware address, that is MAC address, right? So I will explain another important protocol, ARP, address resolution protocol, later on. So for now, you can understand that in network, uh, a lot of messages are sent as broadcast message. Broadcast message means not any specific message, the last address of network, last address, right? Last address of that network. Okay. So what will happen? That message will hit to all the end devices. I mean, like if total there are 500 computers in a network, and if one of the computer is generating broadcast message, so 499 computers all get that broadcast packet. Why? Because all 500 computers are in the same network, are in the same network. And broadcast, we cannot completely stop broadcasting in a network, right? There is no way. So broadcast, yes, will keep on happening in the network. Broadcast messages sent like periodically and maybe at the time of communicating with another computer. So I will take one or two scenarios so you will understand. So problem here is, and even in case if one of the computer got compromised, right, maybe infected with virus or something. So since all 500 computers are in the same network, there is no network segmentation. So there is like a very good chance that the rest 499 computers might get infected. If one of the computer is compromised, so yes, like there is free flow, lateral movement can be done then. So from these perspective, a big network, a network of 500 computers even, not like never suggested, right? Not a best practice. So what is the best practice? Network segmentation, right? Keeping network size or subnet size very small, right? So even if you have 500 computers, we have class B and A address to use. Of course, we cannot use class C, but we never do that, right? Even like this 500 computers, maybe like we will do like segmentation will logically divide into 4 subnets or 8 subnets, right, for better management, administration, optimization, security reason, right? But the good reason of doing subnetting is what? Minimizing wastage of IPs. This is the good reason, main reason. Other reasons are like just like supplementary. The main reason of doing subnetting is first one, judicial use of IPs minimizes wastage of IPs. So that's what subnetting is. Let me jump to this presentation file now. So it was just high level overview of subnetting. So a subnet or subnetwork is a logical subdivision of an IP network. The practice of dividing a network into two or more networks is called subnetting. So subnetting is a technique or method of division or dividing a network into a small networks. And a subnet is a subnetwork of a network that falls within the same class A, B, or C range. So subnet means a small network. Even opposite of this is also possible. Let's say if you have a network of 254 computers, there is another big network of 254 computers, and you want to merge both networks, right? Very rare, like in routing or some other advanced scenarios, this may be required. And I'll take one or two examples to like explain this. But that is also possible, right? We can aggregate, summarize multiple networks into a very big network, right? A very big network, and that big network is known as supernet. So if network size has grown in size, I mean, like multiple subnets logically combined, multiple networks rather, I would say, multiple networks logically combined, that is known as supernet, a big network, right? And if a network is logically divided, then known as subnet or subnetwork. So in networking, yes, we use both terms, subnetwork, subnet, and also supernet, means like uh, putting like multiple networks all together. So both are possible. Now, how to do all this? I mean, like how to create subnets. So creating subnets or subnetworks is essentially the act of taking bits from the host portion of the address and reserving them to define the subnet address instead. Clearly, this will result in fewer bits being available for defining your host. So it's very difficult to understand from this presentation file how it is done, right? So let me take one example here so that you can understand subnetting. And just give me 5 minutes. Let me try if by changing cable, if my digital pad start working, so it would be beneficial because my digital pad is not working today. I don't know what has gone wrong. Probably the cable. So just hang in like for 2 or 3 minutes. Just give me 2 or 3 minutes. I'm just going to try with another like cable. Probably if cable is faulty, then will start working because I need my digital pin today, especially for the subnetting. So just hold on for 2 or 3 minutes only. Sorry guys, I'm back. So I just connected another digital pad. So luckily I got another one. So as a backup. All right. So now uh, how to do subnetting? I mean, like if like let me take one example. So here we have a class C network, class C, and let's say network address is class C network address is 192.168.1.0/24. Slash 24 means like 24 ones like this. 336 to 8, 1 2 3 36 to 8, 3 3 6 8, and then 1 2 3 4 5 6 7 8. Right? Or we can also write in decimal 255.255.255.0. Now here my objective or requirement, let me take one objective here. Objective is to have 4 small networks, means subnets in this, right? So my requirement is like 4 subnets. In this network, there should be 4 subnets, right? Now, how we, I mean, like here, like there is a network. A network has total 254 hosts. And now my requirement is to divide this network into 4 subnets. And obviously, like if a network is divided into subnets, means like number of hosts per subnet would be less than 254 because we are doing logical division. And a small network is treated as a completely different network. So a small subnet means a completely a different network. But how do we do all this? I mean, like how to start doing subnetting, computation, calculation, what is method? So first step here, after understanding, like knowing the requirement, like for example, in this example, objective is to divide class C network into 4 small networks or subnets. That is requirement or objective. So now the first step here is what we do basically. So and if you look at the subnet mask, then 24 bits represent network portion. Ones, 24 ones. We have 8 zeros. Zeros means host portion. So network and host portion. And now we, like I'm introducing the third term. And the third term here is like already we have like network bits, we have host bits in IP address, network bits and host bit. And now the third term here is subnet, subnet bits, right? But we don't have a scope here like take like subnet bits. I mean like total 32 bits IP address, already 24 network bits, and 8 host bits. And total, if we add both 24 plus 8 is equal to 32 bits. 32 bits IP address. But now there is third term, and that is subnet bit, subnet ID or subnet bit. So what we do in subnetting, and that's the first step, we borrow subnet bit or bits from host portion or host bits. We cannot do anything with the network bits. 24 and will remain minimum 24. We have 8 bits here for the host. So what we can do further, we can borrow subnet bits from the host portion. Means if we take, let's say, 3 bits, like we borrow 3 bits from the host to use for like this subnet or subnet bits. So obviously host bits will get reduced now, right? And host bits will be only 5 now, because total we have 8 bits. So 8 bit are bits further divided, right? Maybe 3 and 5, or maybe subnet bits, let's say 2, then 6 host bits. Subnet bit, if 4, then 4 host bits. Subnet bits 5, then host bits 3, right? Because total we have 8 bits. So we can manipulate, like, I mean, like, we can like take 2, 3, 4, 5, 1 bits from host portion as a subnet bit, and remaining host bits. But how many bits we will have to borrow from the host portion, again, that depends on requirement. What is requirement? What is objective, right? A requirement. So here, like, the requirement or objective. So either like divide network into 4 small networks, or we can say like to have 4 small networks, one of the same thing. So based on the requirement, we decide how many bits need to be borrowed from the host portion, because that's the very first step. So because in first step in subnetting, what we do, we figure out or finding out subnet bits, and subnet bits are borrowed from host portion or host bit. And the first step is finding out subnet bits. How many bits we need to borrow from here? And total we have 8 bits. So you understand, you cannot borrow 10 bits or 12 bits. No, not possibility. At least in class C network, you understand that, right? In class C network, total we have 8 bits, right? Because you cannot do anything with the network bits. So maximum we can borrow 7 bits, or 6, 5, 4, 3, 2, 1. That's right. But how many bits? So again, here we use a formula, and formula is maximum number of subnets is equal to 2 raised to the power n. And what is n here? N is equal to number of bits borrowed from host portion. That is your n. Let me put it in simple way. So if number of bits borrowed in subnet bits, if I write down here and here, maximum number of subnets. So you can easily calculate this. Let me, if I just write it down here. Now, if we borrow one bit, so 1 bit means number of subnets will be equal to 2 raised to the power 1, that is 2 subnets. Now, if we take 2 bits from the host portion, so will be equal to 2 raised to the power 2 means 4 subnets. 4 subnets. If 3 bits borrowed, if we borrow 3 bits, we take 3 bits from the host portion, then equal to 2 raised to the power 3 and equal to 8 subnets. 8 subnets. If we borrow 4 bits, then equal to 2 raised to the power 4, means total 16 subnets. 5 bits, then 2 raised to the power 5, 2 raised to the power 5, and equal to 32 subnets, and so on, right? So you understand like how it is computed, the way like how it is computed. So now, if objective is to have like 4 networks, so yes, like we are going to borrow 2 bits from this 2 bits. And if 2 bits are borrowed, are used for subnet, then remaining 6 bits will represent host bits or host portion, because we are basically taking like subnet bits from the host portion only, right? And what if objective is to divide a network into 6 subnets? Let's say this network has to be divided into 6 subnets. Then how many bits will have to borrow from the host portion? So of course, if you look at this table, so either like network will be divided into 2 subnets, 4, 8, 16, 32, right? So there is no way to divide network into exactly 6 subnets. So what we do then, we just try to reach out to the nearest figure, but on higher end side. Means if 6 subnets are required, then definitely we would follow this one. Even though if we borrow 3 bits, means the network will get divided logically in 8 subnets. Requirement is 6, but yes, like we'll have to take this one. We cannot go with this 4 subnets, right? Nearest, but on the higher end side. Exact figure, no. It's all in binary, 2 raised to the power. So you understand. You can never have like 3 subnets, 5 subnets, 7 and 9 and all that. No way. So this is the first step. So first step here is what? First step is finding out subnet bits. This is the first step. So once decided, let's say now we have decided subnet bits decided, right? So subnet bits decided, we have determined the subnet bits, and what's the final decision now, conclusion? Subnet bits is equal to 2 and host bits, and just I'm taking only one example today. In next class, in next session, we'll do like 4 5 more examples, right? So probably like one example would not be enough to understand subnetting properly, but even if you are able to understand 60-70% of it, more than enough for me, because I know like in next examples, then you would be able to catch things properly. So host bit 6. So step number 1 done. Step number 1, finding out subnet bits, means bits that need to be borrowed from host portion. And in determining subnet bits and host bits, objective or requirement will play important role. So based on the requirement objective, we will decide subnet bits and host bits. Step number 1, right? So now 24 bits network, 2 bits again network, but a small network or subnet, and host bits 6. So from here, we can further draw another conclusion, and that is maximum number of subnets will be equal to 4. And you understand why 4? Because 2 bits, so 4 means 2 raised to the power 2, right? Equal to 4. 2 raised to the power 2 equal to 4. And then maximum number of IPs or hosts per subnet will be equal to 2 raised to the power host bits, that is 6, and minus 2. Why minus 2? Because 2 IPs are reserved. 2 IPs are reserved. Right? 2 IPs are reserved. Which one? First IP and last IP. First IP and last IP. 2 IPs are reserved. So in host, we will have to subtract 2. So end result here would be 2 raised to the power 6 means 64, minus 2. So I believe 62. So how do we compute? So basically, now this network, a big network, will be divided into 4 subnet, 4 subnet. And why 4 subnet? Because 2 bits are borrowed and 2 raised to the power 2 is equal to 4. And now each subnet now will have maximum 2 raised to the power 6. And why 6? Because 6 bits host portion now. So 2 raised to the power 6 means 64 and minus 2, that is 62. Means 62 IP here and 62, 62 and 62. So 62 IPs in each small network. So basically this class C network is further divided into 4 small networks, and each small network would be treated as a network basically. Means 62 IPs, right? And just very basic example I've taken today. Now we have finished step number 1. Step number 2. Once like you have decided like host and subnet bits are determined, first step is completed. So determine subnet and host bits, right? Subnet and host bits. And your like objective or requirement will help you to like find out host and subnet bits. Objective requirement, right? So it's a fixed requirement, right? I took like 4 small networks, can be 16, can be 10, 20, 30, right? Any number. And then based on the requirement, I chose like subnet bits 2 and host bits 6. And this way total 4 subnets, and each small subnet would have 62 IPs. Step number 2. Now step number 2 is what? Step number 2, because step number 1 was this. Step number 2 is write down subnet mask in binary, and subnet bits are also represented with ones, right? Ones. Subnet bits means network and subnet bits both will be ones in fact. So write down subnet mask in binary. So now subnet mask, and now I'm not going to use default subnet mask. Subnet mask will be 1 1 1 4 5 6 7 8, and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 3, 4, 5, 6, 7, 8. And now 1, 1, 0, 0, 0, 0, 0. That's the way how subnet mask is written now, right? Means already 24 bits for network, but now these 2 bits are also very much like similar to the network bits. However, known as subnet bits, a small network, but in binary, either we use zeros or ones, right? So subnet bits are also represented with ones and host bits as usual zeros. Now, once is written down and convert in decimal, right? So convert this in decimal then. So we have written in binary, and now we are going to convert in decimal. And now you understand like why yesterday we talked about like decimal representation. So in decimal representation, all ones means like 255. Again here, all ones means 255. All ones means 255. And here, this would be 128 plus 64. What would be the value here? This one.
192.
Correct. 192. So now subnet mask is custom. No more is a default subnet mask. Class C subnet mask, but very different than Class C. So now subnet mask has become 192 in the fourth octet. This is the subnet mask. Now step number 3. So what is step number 3 now? So first I'm going to take a like I'm going to suggest you a shortcut method, and shortcut method is compute or find out a block size. Also in subnetting it is known as magic number. And what is magic number? What is block size? So basically subtract subnet mask value, here is 192 from 256. So whatever subnet mask value comes here, this value need to be subtracted from 256. Later on, I will explain like the reason, but this is the shortcut method and the best method, easy to remember. And even we also use the same method in doing subnetting. What I'm suggesting you, right? And the logic I will explain later on. So what need to be done here? So in order to get a block size, a magic number, whatever value comes here, right, other than the default value, subtract this value from 256. 256 is the maximum, not value, but because the value wise, like one octet means what? One octet means 0 to 255. But 0 to 255 means total 256 numbers. 0, 1, 2, 3, because 0 is also included. It's like 0 to 9 means not 9 numbers, it's a 10 numbers total, because we are counting from 0. Same here, in any octet, value is like 0 to 255, but total numbers is equal to 256. And why we have done this, so you will get the answer. But this way, just find out the block size, and the block size here is, let me write down, block size is equal to 256 minus 192 equal to 64. 64 is the block size. And then the last step, only 4 steps here. Write down subnet address range of IPs and broadcast address in of the subnet. Broadcast address of subnet. And you understand, like broadcast and subnet address both are not used, both are reserved. Uh, we will be using like subnet address later on, but broadcast address no, use internally by end devices. We never use them. So this is step number 4. So we started with step number 1, finding out subnet and host bits, then writing down subnet mask in binary and then doing decimal conversion. Third step, finding out block size. Now the question here is, now if a network is divided into 4 subnets and the original network was 1.0, means like IP, valid IP starting from 1 to 254, a single network of 254 IPs, right? But what we did, we divided this a big network, class C network, into 4 small networks. Network 1, or subnet 1, subnet 2, subnet 3, and subnet 4. 4 subnets. Now, what would be the IP range in each subnet? We will have to find out that range of IPs, from where I should start assigning IPs to like computers in this subnet, in this subnet, in this subnet, because like we cannot use 1 to 254 now, because this network has been divided into 4 subnets. So we need to find out that value, right? So quickly, if I write it down here, I will just here like the serial number, and let's say first network, and then here if I write down subnet address, first address, subnet address. And subnetting is all about doing practice. A lot of like practice would be required. I will give you 2 or 3 scenarios of like this subnetting based question, maybe by tomorrow morning, or if I would be able to spare out time, then maybe tonight also. I will like give you like some questions for doing your like practice, in fact, because subnetting is all about doing practice. Range of IPs in each subnet, and the last one is like broadcast address that is not used. Now see here, the first subnet address will be 192.168.1.0, and if I write down subnet mask in this notation, slash notation, so now I will not be using slash 24, no, total 26 ones. So I will write down slash 26, or if in decimal 255, 255, 255, and 192 in decimal, right? Slash 26. Why 26? Because now there are 26 ones, 26 network or subnet pairs, and range of IPs from where I'll be using. So let me write down second subnet, third subnet, and fourth subnet. So how to find out the next subnet? And here, your block size, this magic number, plays important role. How? So this value, 64 value, add to the fourth octet, right? And just keep on adding 64 on its fourth octet. And why fourth octet? Because we borrowed, we have done everything in the fourth octet only. Initial 3 octets unchanged, right? We have done everything in the fourth octet only. So just keep on adding this 64 in fourth octet, right? And automatically you will end up with this 192, the same value automatically. Let me show you. 192.168 1 dot, and then I'm adding 64 here. So 0 and then 64. And obviously same mask. What about the third one, third subnet? 192.168 1 dot, again add 64 to this, 64 plus 64, 128. and then the fourth one here, 192.168.1 dot, and then 192/26. So if you add 64 again here, right? So this would be 192. So, and 192 was the last number, in fact, last digit. So this way, all four subnet addresses means the first address we have computed, but we cannot assign first address to any host device, right? First address. So what is range of IP address? So IP that we would assign to computers would be from 1.1, because 0 is reserved in this subnet, to 192.168.1.62, and 63 is the broadcast address. And how? Let me explain this also. 63, and let me write down another one. Then probably you will understand. So let me complete this table, and then I'm going to explain that. 65 to 192.168.1.126. For this subnetting also, like calculator is available. So subnet calculator, even like there is app also for Android and iOS based. So you can use that application app for subnet calculation, but not recommended, right? You should understand the logic, because would be really very helpful in understanding advanced networking. So I always recommend everyone to understand the concept rather than just using any uh, app or any tool or software, in fact. So better you should understand the concept here. And let me make a space so that you can properly see what I'm writing here. Okay. All right. And here, 192.168.1 dot 129, then 190, and 192.168.1.191, and the last one from 192.168.1.193 to 192.168.1.254, and 255 is here. So how I have written everything here. So look at this number: 0, 64, 128, 192, right? Means the block size 64 magic number I added to the fourth octet, and just I kept on adding till I got this number 192. So this way, four subnet address, like the first address of each subnet, as we know, reserved, last is also reserved. First and last cannot be assigned to any network device, right? Valid IPs can be assigned only, and valid IP range is this only: 1 to 62. 62 IPs, again 62 IPs, 62 IPs, and 62 IPs. So basically, a network is divided into four subnets, and 62 valid IPs in each subnet. First and the last address of each subnet cannot be used, reserved. So total 8 addresses reserved now. 8. Why 8? Because 1, 2, 3, 4. First and the last address of each subnet. First and the last address of each subnet reserved. Right now, uh, how I have done the computation. So what I did, I started with 1.1, and the last number here is 64, but 64 like is the beginning of next segment. So obviously the last number would be 63, but the last address is broadcast address reserved, so I took 62 here. Again, if you look at second, so I started with 65. Look at this. The last digit 128, 128 is the starting of next subnet. So basically last is 127, but the last address is reserved. So I used here like 126. Similarly, 129 and here 192 means 191 should be the last one is broadcast. So 190 is the valid. And then again I started with 193, and we all know like the maximum value is 255, that is again the last address. So 254. And here before I just uh, explain anything else, let me quickly make this diagram. So now let's say there are two computers here connected with a switch. If I assign IP address 192.168.1 dot maybe 130 and mask 255 255 255 dot 192, and here IP address 192.168.1.60 and mask 255 255 255 dot 192. Now what will happen? Both computers will not communicate with each other. This computer is in different subnet, and this machine is in completely different subnet, right? So basically there are two subnets, there are two different networks, they will not talk to each other, right? Even though they both are from the same class C, but network portion, network bits, not same, because we will not have to match only 3 octets. No, not only 3 octets. 3 octets, of course, matching, but not 3 octets, means not 24 bits. Now 26 bits should be same. 26 bits. Because now network bits has have been increased to 26, right? 26. And without doing conversion from decimal to binary is very difficult to figure out like 26 bits same or not. But since we have this table, right? So on the basis of this table, easily we can answer this question. Because 60 IP means like falls in this range, 60, 1.60, and 130 is somewhere in this subnet, subnet number 3. Different subnets. Only there will be a network of 62 computers, 62 computers, 62, 62. 62 computers will communicate. Other 62 will communicate with each other. All right. If we are using default subnet mask, that is 255.255.255.0, then obviously they both will communicate then, because class C address initial 3 octets same. Yes, they will communicate. But since we are using .192 in the fourth octet, total 26 bits as network, means 26 bits of this IP should exactly match with 26 bits of this IP address, and will never match, right? So even if you do, like let's say if you don't have the table, let's say 192.168.1.60, right? So obviously 192.168.1, like it looks like, and even you can do conversion as well, uh, decimal to binary if you want. So 192, I believe, will be 5, 6, 8, and then 168. And how we do decimal to binary conversion? So it's like 192, 168. So basically we have position value like 1, 2, 4, 8, 16, 32, 64, and 128. Now we'll have to figure out, right, how we can get 168. I mean, like, what values or value need to be added together. So if we take 128 from here and 32 again here, Then 128 plus 32 means 160, and then 8. So after adding these three, right, 128, 32, and 8, we will get 168. So we just have to put the value here corresponding to these numbers, and uh, here 1, 1, and 1, and zeros at other places. So 1, 0, 1, 0, 1, and then 0, 0, 1 is equal to 128, right? It means we will have to make combination from these values, these numbers, to get this 168. We cannot go like this 160 plus 8. No, we cannot do that, obviously, because position values like 1, 2, 4, 8, 16, 32, and so on. That means if I have to convert this 168, so 168 is 1, 0, 1, 0, 1, and then 3 times 0. Right? Just for confirmation, if you do reverse like conversion, I mean, like if you again do this way 1, 2, 4, 8, 16, 32, 64, 128, then yes, like you will get same like 168 now. And similarly, the third is, and every time you don't have to write down, right? It's just about doing some practice. And probably I will give you some lab exercises by tomorrow so that you can do your lab exercises. So like this one, like yes, one easily you can convert this one, no problem. So let me write down this one. One means like 1, 2, 3, 4, 5, 6, 7, 8 is one. And then 60. So now we understand 60 is something like, um, if I start from here, so the first one is 128, and then 64, we cannot take 64, then 32, yes, we'll have to take 32, right? How I'm doing calculation? So I know like here, like first one is 128, so value is 60, so I cannot take 128, so it's 0. And then 64, again cannot be. The third one is 32, is 1. And then 16, so if you take 16 here, then 32 plus 16 equal to 48. And then 8, if you add again 8, so is 56. Then 4, and 4 means like 60. Done. Means uh, from here, from left hand side, first two bits should be 0, and then 1, 1, 1, 1, 4 times ones, and then two zeros. So like here, so this is equivalent of 60. I'm doing reverse calculation, reverse calculation. So this is 60. Similarly, if I take this IP, let's say 1 dot, or maybe 129 or 130 maybe. So easily now you can do the conversion, and let me copy and paste this number here. Okay. And here now, you don't have to write down every time. 130, you understand, like the last one is what? 128. 128 plus 2. So 128, 64, 32, 16, 8, 4, 2, 1. Done. It's 130. So easily I have written 160 and 130. Two IP. So we know like 60 IP is from this subnet, right? Look at this subnet, 60 IP, right? And 130 will be from this subnet. So will they communicate? No. Why? Because they both are in different subnets. And why different subnets? Because mask is 26. Initial 26 bits. 26 bits define or represent network bits. So from binary also we can figure out, right? How? If you look at the bits here, so 24 bits same, And here 25th bit is 0 and here is 1. Not same, right? Only 24 bits are same, not even the 25th bits. So they both will not communicate with each other. So basically, once in subnet mask means 26 ones define network portion, and that network portion of IPs should match, should be same. So if 26 bits of first IP address and 26 bits of second IP address, if matching same, then yes, they both will communicate, but not matching here, right? 10 and here 00. 26 bits not same. Even you don't have to do all this calculation. Even we have this this a table. So from here we understand like uh, 60 IP address is like from this range, 130 from this range, both different networks, different subnets. So if we assign like IPs and we try to communicate, no, they are not going to communicate. To prove this, let's do that in packet tracer. Take two computers, assign IP address from two different subnets, same class, but they will not communicate, right? So that's what we want to see here. So double click. In the meantime, it will take time packet tracer because it requires active internet connection. So let me read out like the first presentation file first. So now you understand a subnetwork or subnet is a logical subdivision of an IP network. The practice of dividing a network into two or more networks is called subnetting. A subnet is a subnetwork of a network that falls within the class A, B, or C range. And if I go to the next slide, how to create subnets. Creating subnetworks is essentially the act of taking bits, right? Borrowing bits from where? From the host portion of the address. And exactly the same thing I did. I borrowed subnet bits from the host portion, right? And reserving them, like the borrowed bits are basically subnet bits, right? Clearly, this will result in fewer bits being available for defining your host. Yes, because if in class C total there are 8 bits for the host, and if we borrow 2 bits, or we take 2 bits for subnet, obviously host bits would be then 6. If we borrow 3 bits, then host bits 5. So yes, fewer bits being available for defining your host. Very true. Okay, now in order to subnet a network, extend the natural mask, means the default mask or natural mask, with some of the bits from the host ID portion of the address in order to create subnetwork ID. For example, if given a class C network of this, right, which has a natural mask of 255, 255, 2550, you can create subnets in this manner. How like? Okay, so it's like binary representation is not of any use for now. So just look at this mask only. After doing subnetting, if you get like mask like this, means what? 3 bits must have been borrowed, right? Otherwise, natural mask of class C is what? 255, 255, 255 dot 0, right? But here, what I see, 24 ones plus 3 extra bits, so must have been borrowed from where? From the host portion. And if 3 bits are borrowed means total now there will be 8 subnets, 2 raised to the power 3. And how many subnet hosts per subnet? 2 raised to the power 1, 2, 3, 4, 5, right? 5 zeros and then minus 2, right? And I hope you all understand why minus 2. because first and the last both are reserved. That is why. Now, is equal to 30. So with this, even just looking at the subnet mask, right, I'm in a position to draw some conclusion from here just by looking at the subnet mask. And what I can conclude on the basis of subnet mask, that default network address class C must have been logically divided into 8 subnets. First conclusion, why 8 subnets? Because I can see 3 bits borrowed from the host portion. So 2 raised to power 3 means 8 subnets. And now there are 5 bits for host. So I can also compute hosts per subnet, and that is 30, because 2 raised to the power 5 means 32 minus 2 means 1, 2, 3, 4, 5, 6, 7, 8 subnets, and each subnet with 30 valid IPs. So I've done these two conclusions. First, like network divided into 8 subnets, and each subnet would have 30 valid IPs. And the range, how like we can compute the range of IP. So now, if I have to find out the block size magic number, so the rule is what? Subtract the value, this value, from 256. So it's 224. And after subtraction, the block size would be 32. 32 is what? The block size. And then just keep on adding 32, keep on adding 32 at the fourth arcade. You, you, you will get that. Then you will get the answer, right? So by extending, and in the beginning, as I mentioned, like the most difficult topic we are covering, so only 1 or 2 examples wouldn't be enough to understand subnetting properly. So we would have one more session for the same like subnetting, right? So I will recap everything, and then I will take a couple of more examples to explain subnetting in detail. So rest assured, like that's not today is not the only class like based on subnetting. I will take one more session of subnetting. So no problem. Even if you are able to understand 50 to 60% of the concept, more than enough for me. No problem. So now by extending the mask to B 255.255.224, you have taken 3 bits, right, from the original host portion, true, of the address, and use them to make subnets. With these 3 bits, is there any question? Okay, yeah, I understood. Good. And with these 3 bits, it is possible to create 8 subnets. Yes, 3 bits, 8 subnets, 2 raised to the power 3. With the other 5 host ID bits, each subnet can have 30 hosts. I believe you all understand like how like both computed subnets and hosts. So just you need to look at ones and zeros. Whenever you compute number of hosts, don't forget to subtract 2 minus 2. In subnet, you don't have to subtract anything. But in host, yes, because first IP, last IP, both not used. And oh my God, if you look at this table, but in this example, 3 bits, right, have been borrowed, 3 bits. And see here, because the main task is what? Writing down subnet mask. That's the main job, right? And how to do that? Get a block size. Block size here would be 32. And see here, 0, 32, then add 32 again, 64, one more time, 32, 96, then again 32, 128, 32, 160, 32, 192, 32. 224, right? So we would end up with the same number, 224. So this way, if you count in total 1, 2, 3, 4, 5, 6, 7, 8, 8 subnets there, and they all would have the same subnet mask. If you want to write down subnet mask in slash notation, CIDR format, this format, so 8 ones, 8, 8, and 3. So 24 and 3. So what we can write here? 27. So either write down this or 27 only, right? One of the same thing. If you want to write down in decimal representation, yes, 224 is the mask. If you want to use slash notation, then slash 27. Okay. And then once like you have written subnet address, then range of IP is very easy. Why? Because 0 is the first and 32 is the next one. So 31 will be the last, but 31 last is what? Broadcast address. So valid IP is 1 to 30, 30 IPs. And you can see 30 IPs. A network of 30 IPs. Then again here 32. So you start with 33. We may go up to 63, but 63 is the last. So last address is this. So we are computing address like this, taking like last two digits of each subnet. And this way, we have written down everything. Range of IPs, broadcast address, subnet address, right? So it was just one example of doing subnetting. And here I have opened, and let me quickly show you like the concept. So if I take here computer 1 and 2, I'm keeping things very simple. Okay, and connected and connected. And I'm going to use first like the same one address like 60 and another 130, right? We'll see like both computers will not communicate with each other, And I'm going to assign IP address 192.168.1.60. I'm not going to use default mask. With default mask, yes, they will communicate. So I'm going to use 192. And here 130 IP 192.168.1.130, and mask is again here not 0, is 192. Okay, and then just let me. Okay, now I have assigned IPs to both computers, and this machine IP is 192.168.1.60. And if you look at the mask means subnet mask. So subnet mask is not default 192. And here IP address 192.168.1.130, and subnet mask or mask is not the default 255.255.255.192, right? So both computers are not in the same network. Physical network, yes, single physical network, but logically two networks. And how we can verify this? So if I double click one of the machine, just a minute. So desktop command prompt. So I'm on PC1 and I'm trying to ping with computer 2. Computer 2 IP is 1.130. 1.130. That's true. Enter and see here. Not communicating it with each other. Why? Because they both are not in the same network. What if I assign IP address from the same subnet? Any IP address from this range, or maybe IP address from this range only. Like 160, I assigned maybe 129, 130, or something, or even 160 to this machine. Instead of 60, 160. So yes, then we'll communicate. So here, now I assigned 160 now here. 160. So 160 and 130. So if you look at the table, so 130 and 160 means same range, same subnet. So yes, they will communicate. So if I again try to ping from here to again the same IP 130, and yes, they both are communicating, right? So we have done like verification from packet tester by using packet tester, particularly also from this table also, right? Multiple ways from this table also, and even like showed you like another method here. Even we can, if convert decimal into binary, so we can match 24 bits. If 24 bits identical, matching, same network. Not matching, different network. Same networks will communicate, different networks will not communicate. We can make that communication to happen, right? Different networks, but that is something different. That's what routing is, right? So we will understand routing in later on, because with the help of router, another network device, different networks communicate with each other. So but that's something like uh, with the help of a gateway, a router, in fact. But without routing or without router, no, not possible. So if any question, any doubt, so you can ask your question here. And I understand like subnetting is a bit of exercise lab, like doing some mathematical computation practice, right? Taking up 5 to 10 different examples with different objective, different requirement, and then following the same method. And what I did, I first computed, or I just found subnet bits and host bits, right? And totally it is based on requirement. I'll take a couple of more examples in next class, right? So you would be more comfortable then. But yes, first step is find out subnet and host bits. And subnet bits are always borrowed from host portion, taken out from the host portion. And then next step is write down subnet mask first in binary and then convert in decimal. Third step is finding out a block size, and very easy method or shortcut method. You don't have to do much computation here. Most of the people use the same logic, same concept that I have explained here. Whatever value you see here, you find here, other than the default, the actual one, subtract this value from 256, right? To get a block size, a magic number, also known as a magic number. So get the magic number, a block size, and then life is very easy. Why? Because just keep on adding this number to the fourth octet. And why I'm adding to the fourth octet? Because we have done everything in the fourth octet only. Initial three octets, nothing has been changed, intact. Only the fourth octet, right? All the manipulation in fourth octet only. That is why just add this block size in the fourth octet, 0, then add this 64, 64, one more time 64, means 64 plus 64, 128, again 64, means 64 plus this 128, then 192, and stop here. Even 4 subnets were required, 4 subnets computed, and even we have reached to the same number, 192. So if you look at the subnet mask value, so subnet mask value as 192. Basically, the idea behind this, the finding out the block size, magic number, and all that is like just doing equal division of a network into 4 subnets with equal number of subnets, or sorry, equal number of hosts, right? And once like you have finished writing down subnet addresses, all the 4 subnet address, so easily you can find out range of IPs. Take this number, 0, 0 is the first one. Leave this, start with 1. And obviously the next subnet is starting at 64, so we may go up to 63, but 63 is the last address, so reserved, right? And even if we try to assign 63 or maybe any address from the same range, I mean like reserved, so probably we'll get error message here. This way also we can go, and let me take any last address 63, for example, 63, right? And see, it's just saying like either IP or subnet mask, something wrong here, right? Invalid IP for this subnet mask entered. If you are using this subnet mask 192, then the IP is invalid. Why? Because 63 is reserved broadcast address. But if I change mask to this without subnetting, right? Then yes, I can take 63, no problem. Because if there is no subnetting, then the last address, there will be only one broadcast address, right? Basically, what is happening here after doing subnetting, since before subnetting, there was a big network and two addresses were reserved. First address and the last address. Last address means 255. First address, network address, reserved, and the last address, broadcast address, reserved. Before subnetting, only two and 254 valid IPs. Now, this network divided into four subnets. So now each subnet would have a subnet address and broadcast address, reserved address. Again here, a subnet address and broadcast address, subnet address, broadcast address, subnet address, broadcast address. Means 2 to 4 to 6, 8 more IPs reserved now, right? 8 IPs total reserved now because there are four subnets here. So there is no rule of thumb like that is 255 is always reserved, 0 is always reserved. Yes, 2550 reserved only if there is no subnetting. If we have done subnetting, we have divided a network into different subnets. So yes, the number can be anything. I mean, like not necessarily 255 and 0 always, right? So the good way to remember things is like remembering this way. First address and last address both are reserved. First address is either network address in case there is no subnetting or subnet address. And last address is always broadcast address. Forget about 0 and 255. Forget that, right? First address and last address, both addresses are reserved, right? Forget about this decimal value 0 and 255 because you can see here in this table also all the addresses not ending with 255, right? Here like 31, 63, 95, 127, they all are reserved, they all are broadcast address. Only one IP is 255, others IPs are different. So first and the last both are reserved, and then in between first and last you can use all the IPs this way. So I took example of like four subnets, and this diagram is showing a network divided into 8 subnets, class C. In next class, I will take class A or B also. Same method, nothing is going to be changed. It's only different different exercise only. So only different exercise, maybe some advanced computation or calculation. Rule will remain same. So I'm not going to use any other rule. The same method, 4 steps only. First, finding out subnet bits, write down subnet mask in binary. So that's the way how you will have to do the computation. And I'm just putting this file here also. Let me pause this. Why?
When you go a little up, I have a question in this.
Okay, just give me 1 minute. Let me share this file and then yes. Submitting steps. So in chat window, I am whatever I have written. So I'm going to share here. Steps. Okay, so I have shared this notepad file also, just for your reference. Yes, now go ahead. Now ask your question. I'm done. Yeah. Yeah, yes. You have question?
Yeah, but I have a question. Can you open the
Which notepad file?
not
Okay. Yeah.
go
This
up?
one.
Yeah.
Okay.
So here we borrow no how many bit we borrow?
In this example, we borrowed 2 bits.
Okay, two
Two
bits.
bits.
Okay, my
Because
question is we can find like when we borrow and a bit we can find it like magic, we can find it like the host and a bit in each network.
mhm.
And what if we don't have something we borrow, like what they are all zeros like that? Yeah.
Here.
Like if we don't have anything to borrow, how can we like and break down?
So if like there is no I mean like already if we have a subnet and let's say already mask is something like 8 once, then again once, again here once, and maybe here again like already 6 zeros and hardly 1 or 2 bits here. So yes, like already if the mask is like this means already a very small network, maybe a small network with 2 hosts only, so this cannot be further than subnetted, right? Because this is already the smallest network, so we don't have a space here, because already total there are 2 zeros. So even if we borrow 1 bit from here, so yes, like number of subnets would be 2. But what about the host portion? Then host portion, if we exclude both IPs, then technically this would be 0. However, in some corner use case, especially in Cisco router, there is a provision like that we can use these reserved addresses also. But just hypothetically, I mean like no critical use case, because there has to be minimum 2 bits available for host portion. So if total there are 2 bits already for the host, so yes, that can never be further subnetted then. So there has to be available sufficient host bits right here. Maybe even if like total there are 3 zeros already, so we can borrow 1 bit and we can leave remaining two for the host portion. But if there is only 1 zero or 2 zeros, so no, further cannot be subnetted then, because already then you have got a subnet, a very small subnet, a subnet of 2 hosts only. So you understand already a subnet of 2 hosts. So this can further not be subnetted further, right? Because network means like minimum 2 hosts, in fact. So already you have a subnet of 2 hosts. So this would be the only case wherein like you won't have number of zeros to borrow. Otherwise, yes, you would have like here enough zeros, right? Even in class B, if you remember, so total we have 16 zeros, 16 class B. Even you can borrow 10 bits, you can borrow 6, you can borrow 9, right? And again, that depends on the requirement. What is your requirement? What is your objective? How many subnets really you want to create? Based on that, we decide subnet and host bits. Make sense?
Yeah.
Okay. So it was class C, obviously. In class B, even you'll see like in class B, like here also we find zeros, means 16 zeros. So more room to like for subnets. So more bits can be borrowed from the host portion. Again, like it depends on the requirement, but at least 2 zeros you will have to leave for the host, in fact. So In this example also, we cannot borrow 7 or 8 bits. No, because if we borrow 7 or 8 bits and total there are 7 bits, so obviously like we are not leaving host bits behind. So a network without any host like meaningless. So not possible at all. So like
always we have to have something to borrow in order to find
yes,
the number of
yes,
networks, like to the power of n, and like you said, and to find the, or to create the network, and or to find the, and what they call it, magic, like to the
magic
power of,
number. Yes,
yeah.
block
So
size.
we have to have something to borrow.
Yes, yes,
Okay.
definitely. Because if there is no like zero or zeros here, so we cannot do subnetting further. Subnetting can be done only if like, because already if there is only two IPs, means already a small network of two IPs only, means like here only two zeros only, all ones. So obviously we cannot borrow anything now. Already
Okay,
is like
like this
saturated
one.
already.
Let's say like class C network, we have like an 192
Mhm.
168.1.0.24. So the
Mhm.
24 is an networking portion, which is like,
Yes.
24 zeros. So that means
So
in this case, we cannot do anything. We cannot borrow anything from this and network address unless it has to be 25/25 or 26 or 27, right?
no, let me correct you. There is something misconfusion. So if network address is like 192.168.1.0/24, so /24 means like if I write down subnet mask in expanded form, so 24 means like this 33628, 33628,
Yes.
33628, right?
Yes.
24 ones. And but as we know, like IP address is of 32 bits, so remaining zeros obviously not mentioned here, but remaining zeros means 8 zeros here. So now
Yes.
we can borrow like from here. Obviously we cannot do anything with these 24 bits. So we can borrow 1 bit, 2 bits, 3 bits, 4 bits. Let's say we have borrowed 4 bits. Now mask would become 28. Why 28? Because already it was 24 and we have borrowed 4 more bits. So now the length is 28. So here like there is room to borrow bits in fact. But yes, if you see mask 25, 26, 27, anything in class C network other than 24, definitely subnetting must have been done. Because if there is no subnetting, mask here would be always 24 only in class C. In class C, this would be always 24. So if you see here 26, 27 or something, definitely subnetting must have been done there. But we borrow bits from here, zeros. Let's say if you like see this maybe address 1.0/16. So /16 means 16 ones. So 16 ones network portion and rest 16 zeros. So still we have room for subnet or subnetting because total there are 16 host bits. So we can borrow 2, 3, 4, 5, 6, 7, whatever like we want, like from 16. But let's say you have borrowed 5 bits, for example. So now for host, there would be 11 bits only, right? And now this length would become 16 plus subnet bits will be added 5 and /21. Slash would become 21. So that's the way how computation goes, computation is done. Means that's correct. There has to be a room, there has to be enough zeros to borrow, right? Because if there are only two zeros in the mask, obviously we cannot borrow anything. But if like there are 8 zeros, 16 zeros, 10 zeros, we can borrow them from those like host bits, host portion. I'll take a couple of more examples to explain this further. So, as I mentioned, like subnetting is the most difficult topic of CCNA even, and a lot of computation. Even though like a lot of calculators are available, mobile based, even your desktop based. So you can download free tool, free software. Just put your requirement, like write down this network address. We'll ask how many subnets you want, specify, okay, I want 4 subnets. Then automatically that software will do the calculation and this result will be in front of you. But I want you guys to understand the concept, right? Not like just doing everything with the help of any software or calculator. Do it at your own, because in larger network environment, a big enterprise network, if you are designing a network architect or network design, or there are some different job profiles. So understanding IPs, subnetting, mask, really very, very important, because plays important role in network optimization also. Network segmentation, optimization, routing. It's not only about minimizing like wastage of IPs. At the same time, this subnetting or network segmentation also plays very important role in network optimization. So you'll have to understand the subnetting very well. No problem. So I will take a couple of more examples in next class. Next class would be on Monday. I believe Monday is 1st of Jan. So uh, I'm available. So we would have class Monday. Same topic, subnetting, right? And in the meantime, if you get or if you can spare out time, then definitely you should try to like understand this subnetting uh, at your own also. And if I'll get some like resource for for your lab like exercise, I mean like practice and exercise. So I will share some examples, I mean, for of subnetting and all that. But really very, very important topic this subnetting is. Also shared the notepad like that I used to write down points, point number 1, 2, 3, 4. So you can refer like that notepad also. All right. 2 times open. Let me close this. So